Good day, everyone. Our lesson for today is all about determinants, inversion, and permutation. In linear algebra, determinant is a scalar value that can be computed from the elements of the square matrix and encodes certain properties of a linear transformation described by the matrix. The determinant of a matrix A is denoted by that A or determinant of A, that A, or pwede siyang absolute value of A. So this can be parang representation, three different representation of determinants of A or of a matrix A. Geometrically, it can be viewed as the volume scaling factor of the linear transformation described by the matrix. This is also the sign volume of the n-dimensional parallelepiped spanned by the column or row vectors of the matrix. It has a very important role in linear transformation and vectors. The determinant is positive or negative according to whether the linear transformation preserves or reverses uh, the orientation of a real vector space. So for the definition of the determinants, start with the permutation. So let S is equal to a spaces with the value of 1 to up to n be the set of integers from 1 to n arranged in ascending order. A rearrangement j1, j2, and so on up to jn of an element of S is called a permutation of S. We can consider a permutation of S to be a one-to-one mapping of S into itself, just like the illustration below. To illustrate the preceding definition, let S is equal to 1, 2, 3, and 4. Then permutation could be 4, 2, 3, and 1. That is a permutation. So when we are talking about permutation, it's a position. Diba? We can use 4, 2, 3, 1 as the permutation of S. It corresponds to the function of f, s up to s, defined as f of 1 is equal to 4, f of 2 is equal to 2, and f of 3 is equal to 3. F of 1 is equal to 4, f of 2 is equal to 2, f of 3 is equal to 3, f of 4 is equal to 1. We can put any one of the n elements of S in first position. So, pwede siya. Any one of the remaining n minus 1 elements in second position, any one of the remaining n minus 2 elements in the third position, and so on until the nth position can be filled only by the last remaining elements. Thus, there are the n quantity n minus 1, quantity n minus 2, and so on, 2 times 1 times 1, which is what we call the n factorial of a permutation. So, n factorial. Ibig sabihin, pwede ka maglagay ng position na mas madami doon. Pag sinabi kasing n factorial, halimbawa, how many numbers do we have? We have 4. So, how many arrangement can we have in these 4 numbers? If we will do a permutation of the n factorial using n factorial, how many numbers do we have? We have 4. That's n factorial. And this is equivalent based dun sa binasa natin. That's 4 times 3 times 2 times 1. And that's 4 times 3 is 12 times 2, 24 times 1, 24. So we have 24 arrangements. For the permutation of S, we denote the set of all permutation of S by S sub n. A permutation J sub 1, J sub 2, and so on up to J sub n is said to have an inversion of if a large integer J sub r precedes a smaller one, J sub s. A permutation is called even if the total number of inversion in it is even, or odd if the total number of inversion of it is odd. So, sinasabi lang sa inversion daw from highest to lowest. So, yung may inversion from na even, tawag sa kanya even, kung yung inversion niya is even or number of inversion. Kapag odd naman, the number of inversion is odd. If n is less greater than or equal to 2, there are n factorial over 2 even and n factorial over 2 odd permutation in S sub n. So we have examples. S sub 1 has only one factorial which is equal to 1, permutation 1, which is even because there are no inversion. Wala siyang inversion. 1 lang kasi siya eh. Okay, wala siyang, hindi niya sinasabing from 2 to 1. O yeah, 3 to 1. Kasi 1, parang kalaban niya lang sa sarili niya. So there is no inversion here. But it has a permutation. Because 1 factorial is equal to 1. S sub 2 has 2 factorial, or 2. So permutation yan. So 1, 2, which is even, no inversion. It has no inversion. Okay. Yung 2 factorial, ito yung sinasabi ng 2 factorial. Baka malito kayo. Ang 2 factorial kasi, ibig sabihin yan, 2 times 1. So 2 times 1. Kasi pababa yan eh. From 2, after ng 2, 1, di ba? So pababa. So 2 times 1 is 2. Kaya 2 yung answer natin. Okay? Ngayon, yung 2 and 1, yung 2 at saka 1, pwede mo siyang gawing 1, 2, or 2, 1. Ayan yung arrangement nila. Kaya nga 2 yung permutation niya kasi it has 2 arrangement, which is 1, 2, and 2, 1. Ngayon, sa 1, 2 is even, pero no inversion siya. Kasi, nauna yung 1. Ang 2, 1, yan, 2, 1, has an inversion. Pero it called odd. Bakit? Kasi isa lang siya. It's an odd inversion. Okay, because it has one inversion only. Okay, I hope that na-gets yun. Yung 2 factorial is equal to 2 because we have 2 times 1. Pag sabing 2, we have 2 numbers, 2 at saka 1. Yung 2, 1, pwede mo daw siyang i-arrange ng 2, 1 or 1, 2. Ang 1, 2 has no inversion. Ang 2, 1, meron siyang inversion pero odd siya kasi isa lang siya. Okay? In the permutation of 4, 3, 1, 2, this is a S sub 4 which is it has a 24 permutation, di ba? That is 4 times, apat siya. So 4 times 3 times 2 times 1. Apat kasi yan. So pwede mong paikot-ikutin yan ng 24 times. Ngayon, yun daw 4 proceeds to 3, that's equivalent to 1 inversion. 4 proceeds to 1, that's equivalent to 1 inversion as well. 4 proceeds to 2 is another one. 3 proceeds to 1 is another. 3 proceeds to 2 is another. So 1, 2, 3, 4, 5. After ng 3 proceeds to 2, wala na eh. No? Hindi na pwede yung 2 proceeds to 3. Okay? Thus, the total number of inversion in this permutation is 5. Ito yan. Ito yung okay? 4 proceeds to 3. 4 proceeds to 1. 4 proceeds to 2. 3 proceeds to 1. 3 proceeds to 2. Yan. Hindi na pwedeng 1 proceeds to 2. Hindi siya pwede kasi hindi siya inversion dahil nauna yung small number. Okay? So it has an odd inversion. S sub 3 has 3 factorial which is 3, 1, and 2. 3 times 2 times 1, 6 permutations. So, pwede ko siyang paikutin ng 6 na beses. We have 1, 2, 3, 3, 2, 3, 1, and 3, 1, 2, which are even. And then, bakit even yung ito? Kasi it has 2 inversion. This is not an inversion. 2, 1 is an inversion. 3, 2 is an inversion. Next, 1, 3, 2, 2, 1, 3, and 3, 2, 1 is an odd because it has only one inversion. 1, 2 is not an inversion. 2, 3 is not an inversion. Okay? Next, let's proceed to the definition. I hope this one is clear to the definition of permutation and inversion. Now, let's proceed to determinant. Let A is equal to the square bracket of A sub ij be an m by n matrix. The determinant function denoted by det is defined by det A equals summation of quantity positive negative A sub 1 j sub 1 A sub 2 times j sub 2 and so on up to A sub n times j sub n, where the summation is overall permutation of j sub 1, j sub 2 up to j sub n of the set S equals the bracket or the elements of 1, 2 up to n. The sign is taken as positive or negative according to whether the permutation j sub 1, j sub 2, and so on up to j sub n is even or odd. Later on, you will understand this. Okay, maybe you get confused because of the definition, but later on you will understand how to compute for the determinant. In each term, positive, negative, a sub 1, j sub 1, a sub 2, j sub 2 up to a sub n, j sub n of that a, the row subscript are in the order j sub 1, j sub 2 up to j sub n. Thus, each term in that a with its appropriate sign is a product of n entries of a, which exactly 1 entry from each row and exactly 1 entry from each column. Since we sum over all permutation of S, that A has n factorial. Terms in the sum, another notation for that A is A, and this is also a representation for determinants A. We shall use both that A and the representation or the absolute value of A. If A is equal to the square bracket of A sub ij is a 1 by 1 matrix, then A sub or that A is equal to A sub 11. Kasi 1 by 1 lang siya. If this is a 2 by 2 matrix, so we have A sub 11, ito yung sinasabi kanina, A sub 12, A sub 21, A sub 22. Then, to obtain that A, we write down the term A sub 1, A sub 2, and replace the dashes with all possible elementary of S sub 2. The subscript becomes 12 and 21. Okay? Paano ko ba explain? So, ganito lang yan. Usually kasi, ang unang number ay ang row. So, nasa row 1 tayo at saka column 1. Ito yan. Column 1, row 1. Ito, nasa row 1 pa rin yung A, tapos nasa column 2 na siya. That's why 1 and 2. Sa A sub 2, 1, nasa second row siya, nasa first column. Dito naman A sub 2, 2, nasa second row siya, then nasa second column. Okay? So, to do this, determinants of A is equal to A sub 11, A sub 22 minus A sub 22, 12 times A sub 21. So, paano nangyari yon? Hence, we see that can be obtained by forming the product of the entries on the line from left to right and subtracting from this number the product of the entries on the line from right to left. So, ibig sabihin daw, etong A sub 11 and A sub 22, imumultiply natin. And A sub 12 and A sub 21, imumultiply natin. And then, we will get the difference of the two products. Okay, so, example. Halimbawa, meron tayong 2, negative 3, and 4, and 5. So, 2 times 5, ito yan, which is equal to 10. Which is equal to 10 minus 4 times negative 3, which is equal to negative 12. And negative, negative, that's positive. That's why the answer is 22. And now, this is the determinant of A, which is equal to 22. So, ganun lang siyang mag-solve. Okay, for a 2 by 2 matrix. How to get the determinant? Ganun lang siya. Multiply mo yung diagonal. Okay? Now, how about this one? This is a 3 by 3 matrix. Okay, let me read this, but do not be confused with this, okay? Kasi you will get confused if you will, focus in this one. Pero for the sake of discussing this lesson, we need to read this definition. So then, to compute that A, we write down the 6 terms. So, ito yung 6 terms. Ayan. Pero may nawawala. No, mamaya makikita natin. All the elements as sub 3 of are used to replace the dashes. And if we prefix each term by a and by positive and negative according to whether the permutation even or odd, we find it as this one. So for the determinant of a sub 11, a sub 22, a sub 23, plus a sub 12, a sub 23, a sub 31, plus a sub 13, a sub 21, a sub 32, minus a sub 11, a sub 22, a sub 33, minus a sub 12, a sub 21, a sub 33, minus a sub 13, a sub 22, a sub 31. We can also obtain the determinant of A as follows. Repeat the first and second column of A as shown next from the sum of the products of the entries on the lines from the left. Sabi dito, pwede daw natin makuha yung determinant ng A in a 3x3 matrix ng mas madali. If i-repeat daw natin yung first and second column at ilalagay natin dito sa kabila. So let's see. This one. Write and subtract the number products of the entries in the line from the right or left. So dito yan. 1, 2, 3. So itong mga to, i-add mo daw. Then dito naman 1, 2, and 3. So ito naman, i-minus mo. So una, add mo muna yung mga dito. May multiply mo muna lahat yung dito, tapos i-add mo yung product nila. Dito yung multiply mo din, tapos i-add mo yung product nila. Yung nakuha mo dito, i-minus mo dun sa nakuha mong difference, sum. Okay, dito. Paano ba yon? So medyo nalito kayo, I think. So let's have an example. Let A equals the square bracket of 1, 2, 3, 3, 1, 2, 1, 3, and 3, 1, 2. Evaluate for the determinants of A. Substituting in number 1, we find it like this. So, paano nakuha yung answer na 6? Okay, paano nakuha yung answer na 6? So, let's see. Yung 1, 2, ito yan. 1, 2, 3, 2, 1, 1, and 3, 3, 2. Yung dalawang first and second, i-repeat lang natin sila dito. And then, ayan, ito, gawa ka ng arrow. And then, dito din, gawa ka ng arrow. Dapat masatisfy kasi yan eh. Tapos, 1 times 1 times 2, ito yan. 2 times 3 times 3, ito naman yan. 3 times 2 times 1, ito yan. Then, minus 3 times 1 times 3. I'm sorry. Dito siya nag-start ba? Saan ba siya nag-start? Sa gitna. Pwede naman. 1 times 3. In any order naman siya. So, basta minus siya. Okay? 3 times 1 times 3. 1 times 3 times 1. And 2 times 2 times 2. Pero naka-negative sila. So, multiply mo muna. So, this one, okay, is equal to 2. Plus 3 times 2 times 3, 18 ba? Plus 3 times 6 times 1 is 6. Then this is 3. This is 8. This is 9. Alright. Okay. Next, i-add muna natin yung pwede. So we have 26 minus this one, I think. That's negative 20, no? Tama ba? Negative kasi sila, kaya negative. So the answer is 6. Ayan. So that's how we solve for the determinant of a 3x3 matrix and for the determinant of a 2x2 matrix. So yun lang yung parang pinaka-point lang ng discussion natin to discuss about determinant, how to solve the determinant, and how to compute for the permutation, or if it is an inversion or not inversion, if it is an even inversion or odd inversion. Okay, so that's all about for the determinants, inversion, and permutation. With that, thank you very much for your listening.